Hello everyone, welcome to Parthiva Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 2nd May 2023. The problem statement for today is cake distribution problem. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The problem statement says Geek is organizing a birthday party, so his friends brought a cake for him. The cake consists of n chunks whose individual sweetness is represented by the sweetness array. Now at the time of distribution, Geek cuts the cake into k plus 1 pieces to distribute among his k friends. One piece he took for himself. Each piece consists of some consecutive chunks. He is very kind, so he left the piece with minimum sweetness for him. You need to find the maximum sweetness that Geek can get if he distributes the cake optimally. Okay, so in this problem, there is a cake consisting of n chunks, and each chunk has a sweetness level. A person named Geek wants to distribute the cake among his k friends and himself, such that each friend or each person gets a consecutive piece of cake with some sweetness level. However, Geek is kind and wants to keep the piece with minimum sweetness level for himself. The task is to find the minimum sweetness that Geek can get by cutting the cake into k plus 1 pieces. The pieces must be consecutive, and the sweetness level of the piece that Geek keeps for himself must be minimum among all the pieces. We will be given with that array of sweetness level for each chunk of the cake, and we need to write a function to find the minimum sweetness level that Geek can get. Okay, so this was the problem statement. Let's go through the given examples to understand it in a better way. So first example says there are n chunks. That means 6 chunks of cakes, and there are here k is given as 2. That means 2 people are there. That means and the number of friends that have they have attended the birthday party is 2, and this is the sweetness array where the values are 6, 3, 2, 8, 7, 5. That means 6 values for 6 chunks of cake. So here the output is 9. That means the sweetness level that Geek can get for himself is 9. So in explanation it is given that Geek can divide the cake to this. Geek can divide the cake into k plus 1 pieces. That means 3 pieces, 2 for his friends and 1 for himself. So 3 pieces with the combined sweetness level of 6 and 3, 2 and 8, and 7 and 5, with a sweetness level that is equal to 9, 10 and 12 respectively. So whatever is the minimum among them, so that will be for the Geek. So that's why the output is 9. When we go to the second example, so here we can say that n is 7. That means number of chunks of cake is 7, and there are 3 friends, those who have attended the birthday party. So here we can see the cake has to be divided into 4 parts. That means the minimum part will be for the Geek. So the Geek can divide the cake into these 4 sets. That means these 4 chunks that will consist of 1, 4, 3, 4, 7, 3, 9 and 9. So with sweetness level, if you add all of them, then it will be this much respectively. 1 plus 2 plus 4 is equal to 7, 7, 9 and 9 respectively. So the minimum among these is 7. So that is the sweetness level of the cake which Geek gets for himself. Okay. So I hope the problem statement and the given examples are clear to you. So for solving this problem, we will be using a binary search to find the maximum possible sweetness that Geek can get. The idea is to perform a search in the range of the possible sweetness value for the pieces of cake, and to determine whether or not we can divide the cake into k plus 1 pieces in such a way that the piece with the minimum sweetness is maximized. Okay, to do this, we start with the assumption that the maximum sweetness is the sum of the sweetness of all the cake chunks, and minimum sweetness is 1. We then use binary search to find the maximum possible sweetness in a way that divides cake into k pieces. For each iteration of the binary search, we take the midpoint of the current range of the sweetness level and use it as a threshold for dividing the cake into pieces. We then count the number of pieces that can form using this threshold and compare it with k. If the number of pieces is greater than k, we move the threshold to the right. That means we are increasing the sweetness level. Else we move the threshold to the left. That means we are decreasing the sweetness level. We continue this process until the range of the possible sweetness value overlaps or converges, and we find the maximum possible sweetness that we can assign to the piece with the minimum sweetness. Okay, so here we find the maximum possible sweetness that we can assign to the piece with the minimum sweetness. So here the piece with the minimum sweetness, so we will try to get the maximum one among the minimum. So Geek will get the minimum value, but we even for that we try to maximize that. Okay, so with this approach we will be solving this problem. So let's understand this approach in a better way with this example which I have taken for the first input. So let me open this here. So here initially we will be starting with the two values there. We will be performing binary search of that one. So here for the first step, left we are initializing it with 1, and for right we are adding all the sweetness. That means if there is 1 pieces, it is cut in such pieces that it consists of all the chunks, so the sweetness level will be 31. So if we add all of these, then the sum is 31. So if you take the mid of it, then the mid value is 16. Okay, now with this one what we do, we try adding all the consecutive chunks and see where this level crosses. That means where the sweetness level crosses this mid value. Okay, so if we add this one, 6 plus 3 it is 9, 9 plus 3 it is 9 plus 2 it is 11, 11 plus 8 it is 19. So after this one, when we reach 19, so we can see the whatever is the target that we have reached. That means we were trying to reach the sweetness level of 16, and before adding 8 it was 11, after adding 8 it is 19. So we have got that sweetness level. So with that sweetness level we can see we will get only one piece. So one piece that consists of chunks, first 4 chunks, 1 2 3 4. So the first piece, so the only piece possible is this one, but here the number of here 2 friends are there and one for himself, so the number of pieces required is less. Sorry, the number of pieces required is more, but here the current pieces is 1 only. So what we do, we will decrease the sweetness level. So we will decrease the required sweetness level so that we can divide the cake into more chunks. Okay, that means we can divide the entire cake, that means the chunk of the cake, into more pieces. So we'll decrease the sweetness level. So for decreasing the sweetness level, what we do, we decrement the value of the right. Okay, we are decrementing the value of the right. So here, since we are updating the value of the right, it becomes 15 and left is still 1. So now we will perform that same iteration again. So we'll again check what is the midpoint of it. Midpoint of it is sweetness level 8. Now again we start from the beginning of this array and see where this level crosses. So here for this sweetness level 9, we can see that 6 plus 3, when we add this, then this is crossing that sweetness level 8, that is 9. So one piece will get of 6 plus 3, that is 9. Okay, again this will continue and we will set the sweetness level value. So again until this entire array is traversed, we keep on counting the number of pieces. So again when we start from 2 and end up to 8, so here we can see the current sweetness level is 10. So here the number of pieces is 1, previously it was 1, so now we get a second piece. For the next one, when we add 7 and 5, the current sweetness level is 12. So total number of pieces is 3. So here we are getting 3 pieces. 3 pieces in this one. Okay, but the thing is that whatever is that we are taking the sweetness range which is indicated at the lowest by left and the maximum by the right. So when we consider this one, Then the left one is the sweetness level which Geek is getting. So Geek is getting the sweetness level 1 in this case. That can be maximized. That's why we are not stopping here. Okay, we will stop when the left and right converges. That means left becomes equal to or greater than right, then we will stop. So once this is done, then here we can then what we are doing here, we can see since the number of pieces is greater than k, we require number of pieces as 2, and here we have got the number of pieces as 3. Actually the piece which is reserved for Geek, that we are not counting in this one, because that sweetness level that will be calculated when the loop terminates and we get the value of the left. So we will just check for the sweetness level, we compare with the sweetness level that he has to distribute among his friends. Okay, so we'll just consider the number of pieces as 2 itself. Here, since we have got more pieces, then what we can do, we can then we'll update the left value of left, and so that we can increase the sweetness level. That means we will cut the cake in the minimum, and that means in the lesser quantity, so that we can get the maximum, the more sweetness level. Okay, so now left will be 8 and right is still pointing to 15, whatever in the previous one. So here the mid will get as 12. Now if we again try iterating with this one, then we get the current sweetness level as 19. This one when we add first 4. So here the number of pieces is 1 in this case, and here the number of the current sweetness level is 19, we get 1 piece with that, and the second piece with 7 and 5 we get 12. So mid is also equal to 12, so we get 2 pieces here. Okay, so after that we continue to check if there are some more distributions possible or not. So what we do, since we have got this one, what to say, in this one, yeah, we'll continue in that sequence, and here we have got the 2 pieces here, but we can see that sweetness level is still that can be increased, or the left is not equal to right, so that this loop is continuing. So after that we get a new so the left will still be the same and right will be updated to 15, sorry, from 15 to 11. So in through this one we get the value of mid as 10. So value of mid as 10. So with this one we try to check how many pieces we'll get. So with this we can see first 3, when we add 3 chunks we get the sweetness as 11. So first 3 will form 1 piece, and next 2 will form 8 plus 7 is 15. We will get 2 pieces with this. Okay, now again we will update that and we will again continue, and here we can see here the left is 8 and right is again updated to from 10 to 9. Whatever is the value of the mid minus 1, that we are updating the right. So here we get the mid as 9. So here we can see if the mid is 9, so we can and yeah, so here the mid value is 9. So we again try to divide the cake into those chunks where the sweetness level matches or greater than equal to or greater than 9. So 6 plus 3 it will be 9 here. 8 and 2 again it is 10. So second piece. 7 plus 5 is equal to 12. So we are getting 3 pieces again. Okay, so after that when we try to update this left one, so left will become 9. So now the condition will terminate, saying that left is less than the condition where left is less than 9, that will become false. So whatever is the value we have got, so the value will be 8 plus 1, because before checking this condition the value of left will be updated by mid plus 1. So the value will be 9. So whatever is that value, that will be returned as the output. Okay, I hope this explanation is clear. So with this approach only, let's try solving this problem. I have already prepared the code for it. Let me just copy it here just to save time in typing. So here yeah, so here I have even tried giving comments against each line, so that it becomes easy in understanding. So when we talk about this function, the function uses binary search to find the maximum possible sweetness that Geek can get. The sweetness range is initialized as the minimum possible sweetness that of the piece, that is equal to 1 to the left, and the maximum possible sweetness of the piece of a piece, that is sum of all sweetness values in the array that we are assigning to to the variable right, performing an array of summation of all the sweetness, that means all the value in the sweetness array, so that we are assigning to the right. Then in each iteration of binary search, the midpoint of the sweetness range is calculated. Then the sweetness array is traversed and the sweetness value is added until the current sweetness exceeds the midpoint. At this point, a new piece is formed and the current sweetness is reset to 0. Okay. So whatever the new pieces formed, that we will keep on adding to the new piece count, and we are resetting the current sweetness to 0. This process continues until all sweetness value have been considered. Okay. If the number of pieces that can be formed with the current sweetness is greater than the allowed number of pieces, okay, then the sweetness range is shifted to the right. That means the minimum possible sweetness is increased. That means if the current sweetness is greater than, if the number of pieces that can be found with current sweetness is greater than the number of pieces allowed, then the sweetness range is shifted to the right. That means we will increase the possible sweetness value of the cake chunks. Otherwise, the sweetness shifted to the left. That means maximum possible sweetness is decreased. That means if you are not getting enough pieces, if you are getting only fewer pieces than allowed, then the sweetness has to be decreased. Because if you add the complete cake, the sweetness value is 31. So if you try to give that the value of that to all the people, so the value will be so there will be only one piece possible with a sweetness level 31. So since we have to divide into multiple pieces and sweetness value is not same for all the chunks, we have to decrease the sweetness value. So for that we are doing mid -1. Okay. So after this we will continue until this loop terminates, and when the left and the right bounds of the sweetness range converge, the maximum possible sweetness that Geek can get is found and is returned by the function. So here we are checking this one. Once this loop terminates, then we are returning the value of the left that indicates this is the maximum sweetness level that Geek can get. Okay, I hope this problem is clear to this solution is clear to you. Here again I'll just try to explain this. Here the number of pieces greater than k, here we are considered k, not k plus 1. Okay, this is because the pieces variable in the code which is used here keep track of the number of pieces that can be found with the current sweetness level, and it represents the number of pieces that Geek can distribute among his friends, excluding the piece for himself. Okay, so when we are checking for this condition, so whatever is that left value of the left one, that minimum value in the range of the sweetness, that will be left for him. So that's why we are not checking for himself, because his main focus is to distribute among the friends, and the remaining one, the maximum possible value of the minimum ones among the cake chunks that has been left, that he will give to himself. Okay, so the cake with the minimum sweetness level that he will keep for himself. Again, we are trying to maximize that minimum sweetness value. For that we are using that we are finding optimal sweetness level that can be distributed among k pieces. Okay, I hope the solution is clear to you. So that's it. Only around 10 to 15 lines of code here. 3 4 5, yeah, around 10 to 15 lines of code here. So this is the solution of it. Let me try compiling this code. So here we can see we have got correct output. Let's try submitting the solution. So here we can see we have got correct output for this solution, and it means it has covered all the test cases. So this problem has been solved successfully in Java. So talking about the time complexity of this algorithm, it is in the order of big of n log s, where n is the number of cake chunks and s is the range of the possible sweetness level. Here, this code uses binary search to find the minimum sweetness level that can be used to divide the cake into k pieces, such that the piece with the minimum sweetness is maximized. The range of the possible sweetness levels is from 1 to sum of all sweetness level in the cake. Therefore, the time complexity of this binary search is log s. Okay, because we are checking, we are trying to find the optimum value of the sweetness range between 1 to summation of all the sweetness value in the cake. For each iteration in the binary search, the algorithm calculates the number of pieces that can be formed with the current sweetness level. This requires traversing through all the cake chunks, which takes big O of n time. Therefore, the total complexity of the algorithm is big O of n log s. Okay, so this was a Java solution. Even I have prepared a C++ solution. So let me move to C++ editor. Let me just copy that code here. Again, the logic is completely same, no difference. Only the difference, syntactical difference between C++ and Java, that is here. Apart from that, the logic is completely same. Here also we initialize left with 1, right with summation of all the sweetness value, and that we are assigning to the right. We perform binary search and try to find the number of pieces with the optimal sweetness level. If the number of pieces is greater than k, then we increase the sweetness level by we increase the sweetness level so that cake can be divided into less pieces. If it is the opposite case, then that means if we are getting fewer number of cakes than required, then we are decreasing the sweetness level so that we can cut the cake into more pieces. And whenever this left converges right, that means both the sweetness level overlaps or crosses each other, then whatever is the value of left, that we will return, that is the minimum value in the range that Geek will keep for himself. So this is C++ solution. Let me try compiling this code. Even with C++ solution, we have got correct output. Let's try submitting this solution. So here with C++ solution, it has covered all the test cases. So this problem has been solved successfully with both C++ and Java language. So I'll provide the link for this question and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.